Okay, guys, thank you for joining my class. Today we have alkanones. These alkanones are commonly known as ketones. Either you call them alkanones or you call them ketones. And they have the general molecular formula. We have double R CO. And this double R represent either two alkyl groups or two phenyl group. The R represent either alkyl group or phenyl group. And you see that O is directly bonded to carbon, which can be easily used to differentiate alkanes. Okay, in alkanes, we have the general formula RCO, where R represents the alkyl or the phenyl group. But here we have double R. This prime represents that we have double alkyl groups or double phenyl groups. And oxygen is directly bonded to carbon atom. But here in alkanes, we will always see H attached to this. We will always see RC double bond and we have H here. But here we are going to see only this. So this is very important for us to differentiate alkanones from alkanes, despite the fact that we have some chemical tests to differentiate them. So it is very important for us to know the common members of alkanones. Remember that they still have the same carbonyl functional group. They still have the same carbonyl functional group with that of alkanes. The only difference here is because of the double alkyl group or phenyl group. And knowing some of these members will help us to know how we can prepare alkanones, how they can react with certain reagents, oxidizing or reducing agents, and how we can differentiate them from their friends, alkanes, okay, if there is anything like that. So let us see some few members of alkanones. Let us pay attention and see these few members. Okay. Now the first member, remember that we have double bond, which we cannot ignore. We have this because of we have double alkyl group or double phenyl group. So it simply means that the first group member will start from 3 carbon atoms. Remember, in alkanes, we started from 1 carbon atom, which is HCHO, which is methanol. Methanol is the first group member in alkanes. But here, the first group member in alkanones or ketones is propanone. It's known as propanone. Propanone, 3 carbon atoms. Let us see the second member. The second member will become butanone, because after propanone, we are not going backwards, it becomes butanone. And butanone, remember, we are still having our double bond, which you cannot ignore. We have this CH2, CH3, or CH2H5, and here we have also CH3. So let us see what this compound is known. And what is the longest carbon chain? Please do not get it twisted. If you start your longest carbon chain from here, 1, 2, 3, you are not going to get the longest carbon chain. So for you to get the longest carbon chain, you are going to start from here, 1, 2, 3, and 4. So if such is the case, because this one becomes butan 2-one. Remember that the suffix becomes ONE. We are talking about butanone. Any other suffix you may have encountered in organic chemistry, here you are going to change it with on or on. It sounds on. That is butan 2-one, not 1. Okay, so on. Whatever we see here, the suffix becomes automatically on. Okay. So this is the second group member. Let us continue to know at least 4 members before we continue in our class. So the second member, remember, one thing you have in your mind is that the carbonyl functional group, nothing is attached to the carbonyl functional group. It's always C double bond. Do not forget this. It is always this. You can do whatever you want to do, but this is very constant. See the double bond, C double bond is very compound as far as alkanones are concerned, is very, very important. So we're going to have here CH2, CH3, we're going to have CH2, CH2, and CH3. 1, 2, 3, 4, 5. Okay, and CH3. So we're going to have 1, 2, 3, 4, 5. So if I want to name, I'm going to start from here. So I will have 1. Remember, we are looking for the longest carbon chain. 1, 2, 3, 4, 5. So this one becomes pentane 2-one. This one becomes pentane 2-one. Pentane 2-one, because I want to give priority to the carbonyl functional group, okay, which is the CO here. So the longest chain becomes from 1, 2, 3, 4, 5. If I want to give my longest chain from here, if I say 1, 2, 3, 4, it's not the longest chain. So it is from 1, 2, 3, 4, 5. So it becomes pentane 2-one. This is the next member, pentane 2-one. Let us see if we can get an isomer of pentane 2-one. Isomer of pentane 2-one. Let's see, at least these 4 members will give us an idea of how alkanones or ketones look like, okay? Now, so if such is the case, remember, you do not alter the carbonyl functional group. We are still having our carbonyl functional group. So in this case, we are going to have something like this, CH2, CH3, because we want to get the isomer, the same molecular formula, but different in structural formula. That is what an isomer means. Okay, so in this case, let us see the longest carbon chain here. The longest carbon chain, if you take it 1, 2, 3, 4, 5, yes, is the longest carbon chain, or we can take it 1, 2, 3, 4, 5, yes, which means wherever we are having 1, 2, 3, 4, and 5. So we are still maintaining the molecular formula, which is 5 carbon atoms. We are still maintaining the number of hydrogen atoms, but what has altered here is the structure. So here it becomes pentane 3-one. So these are few members of alkanones. Since you have understood these few members of alkanones, how they look like, if they are presented to you, you should be able to differentiate an alkanone or ketone from an alkyl or aldehyde. So if you have known this, it is now our responsibility to know how to prepare them in the laboratory. So see you in my next class, where we talk about the preparation of alkanones or ketones.